started, everyone. So always nice seeing your pets. One more question I want to cover, the last question in 7.2, and it's a long, and this is my version of it. But before I do that, I want to bring up a problem, and it's really not your problem, it's a kind of WebAssign problem. Do you know sometimes you do the exact value of, you know, the sine of 15 or the tan of 135, you know, that type of question? And you may come up with an answer that looks something like this. Okay, you know, it just ends up being the answer, right? Can you imagine that? Now you type that into WebAssign and it tells you you're wrong, even although you are correct. I can't remember which question it is, but one of my students had this issue. So you may have you ever had an issue where you're 99.6 that that's the right, that's the right answer, but WebAssign isn't accepting it? Has anybody hit that? Not just this one student, I'm sure there must be somebody else. Okay, if you come across a question that looks something like that, and WebAssign is saying it's wrong, will you contact me and I'll just give you the points for it? Because evidently WebAssign has got a little glitch in the matrix, for those who know what the context of that phrase is, where it doesn't accept that answer. It actually will accept, I think it's this one or that one, which I'm not sure which it is, but it doesn't accept that one. Who knows why, right? By the way, they're equivalent. So just in the off chance, if you come across a question where you are really sure that it's right, all I can remember about the question that she gave me was, I think it was like an angle like that, right? It was a tan and it was a negative. So if you haven't reached it yet, you might end up with that problem. Just email me, I'll give you the points and just move on, okay?
Actually, yeah, I did have that problem. It was on, it was tan of 345.
Okay, there we are. So be on the lookout for number 10, because I think what happens is that certain combinations are fine. And then, you know how they randomize the questions and other combinations don't. So you might do the question and yep, it's happy. And you'll do the question, you'll get the weird combinations, and for whatever reason, it doesn't like you. So that's just a kind of, you have not done anything wrong. It's just WebAssign being weird because it can be. Right, here's the guy we are going to be doing this last question. We are going to be finding the exact value of this guy. And all we're being told is what the sine of theta is and the cosine of phi is. If you're wondering, we all know that one. That's called theta. And this one here is the Greek letter phi. You pronounce it like you were saying phi, phi, vo, thumb. Right, that's phi, in case you're wondering. So the sine of theta plus phi, the exact value, and being told that the sine of theta is -3/5 and theta is in the 4th quadrant, and the cosine of phi is -1/√2 and phi is in the 2nd quadrant. And that's all you're being told. So let's set the question up. Isn't this the sine of A plus B, right? Think of that as being your A plus your B. So it's going to be the sine of A cosine of B plus the cosine of A sine of B. But in this world, it's going to become the sine of theta, the cosine of phi, plus the cosine of theta times the sine of phi. Now, I know Americans say theta wrong because you pronounce it theta, but you call it phi. Great. None of you have heard of that Greek letter, so you're now going to call it phi, right? And if you meet another American and they pronounce it slightly differently, you're just going to tell them they're wrong, and the right way of saying it is phi. And if you say it with enough conviction, we'll at least get the Americans to produce one of these two and say it the right way. So here's our problem. We only know some of these guys. We don't know all of their values. I know the sine of theta, that's this guy here, is -3/5. I don't know that guy, do I? Well, actually, I do know that guy. He is -1/√2. That's good. What I don't know yet is what that guy is equal to, and I don't know yet what this guy is equal to. But somehow or other, we've got to figure out a value for those two trig ratios as well. So let's focus on finding out what cosine theta is. And I'm going to use this piece here to do that. You're going to build a right angle triangle. Remember doing those guys? I'm going to put the guy theta here. I'm going to call this fella the opposite. I'm going to call this guy the adjacent. And I'm going to call this guy the hypotenuse. And I might as well write down that the sine of theta is -3/5. Won't the opposite be the 3 and the hypotenuse be the 5? So the opposite is the 3 and the hypotenuse is the 5. I don't care about the negative right now. I just need to know the sizes. Are you comfortable about the sine of theta is 3/5 generates this right angle triangle? We've done that before in other situations. So far, so good? Okay, how long is the adjacent? You could probably do it in your head, but if you can't, at least tell me how you would get it. What's this guy? Pythagoras. What's this guy? Okay, here we go then. Adjacent squared plus 3 squared is 5 squared. The adjacent squared plus 9 is 25. The adjacent squared, well, if you take 9 away from both sides, you get that. And since we are looking at a length of a side, the answer is 4. There. Does that ring some bells now, Pythagoras? Right. Now, all of that work was for one job, to find out what the cosine of theta is. Well, the cosine is, what is the cosine equal to? Let's get some cobwebs, cleaned out the brain now. What's the formula using SOHCAHTOA for the cosine?
Adjacent over hypotenuse.
Great. Now, as far as the numbers go, then that happens to be 4/5. But theta is in the 4th quadrant, okay? Now, if the angle theta is in the 4th quadrant, is the cosine positive 4/5 or negative 4/5?
And negative.
Let's remind you, all sine, tan, cos. You want to change your mind?
Oh, yes, it's positive.
Positive, right? So, a lot of things do not go away in trig. The all sine, tan, cos, SOHCAHTOA, all that kind of stuff. Building triangles, right? They come back in different places. Back again here. So I now know, after all that hard work, that guy is 4/5. Right, the second one. This time we're going to do it for angle phi. And, oops, get my color scheme right. Opposite, adjacent, hypotenuse. In this one, you're told that the cosine of phi is -1/√2. The cosine is adjacent over hypotenuse. So this guy is 1, and this guy is √2. So far, so good. Let's try it again then. What is the length of the opposite side? Could do Pythagoras, but try and do it in your head if you can. This guy squared plus this guy squared equals that guy squared. It's actually an easy number. What's this one? Here's a big clue. One of you should get this.
Square root of 1.
Yes, it's 1. Do you want it? You can check with Pythagoras, but it is 1. Now, what do I want? I want the sine. Okay, well, the sine is the opposite over the hypotenuse. In this case, it's also 1 over root 2. And it's in the second quadrant, which makes it positive again, right? A sine, right, in the second quadrant is positive. So you have 1 over root 2. Right. This guy is 3, and this guy is 4, and they share a common denominator. So the answer would be 7 over 5 square root 2. You happy? I kind of skipped a line there. I multiplied these together and get 3 over 5 root 2. And I multiplied these together and I get 4 over 5 root 2. Well, 3 plus 4 over 5 root 2 gets you 7 over 5 root 2. Cool? We're good? Now, they asked for this one. Couldn't they have asked you for the cosine of theta plus phi, the sine of theta minus phi, the tan of theta plus phi? Couldn't you ask you any one of the 6, you know, the add subtracts that we've done, right? But you would still do basically exactly what I did here. And you'd fill in whatever the missing terms were. And finally get an answer. A couple of things that will always happen if you do it correctly. Do you notice that these 2 guys and these 2 guys are the same 2 guys? You see these 2 here and the bottom? They always will be. So if you ever have a 5 in a root 3 and a 5 in a root 7, you screwed up somewhere, right? Go back to your triangle. You did something that wasn't right. It just, you know, it is what it is, right? The way the math works, these 2 guys end up being the same as these 2 guys if you do it properly. Any questions before we leave that? Because we're going to start a new section. Do you see all these lovely triangles? You're going to be doing a lot of them today. So you're going to get lots of practice at them. But that is the end of addition and subtraction. So here's the new guy in town. There's a lot in section 7.3. We're going to do double angles. We're going to do half angles. We're going to do products, and we're going to do sums. We're definitely not going to get through that today. What I hope we get through today, in fact, I know we will, is a double angle. And we might get started on the half angles. We'll just see how that goes, because there's a lot of work in just double angles. So what these 3 formula allow us to do is to find the exact value of double an angle. So I might know what the exact value of sine theta is, right? I might know the exact value of that. This allows me now to find the exact value of 2 theta, right? So it allows us, we're kind of trying to get a way of getting exact values for as many possible trig angles as we can. But these questions, you aren't normally told what the angle is, right? They don't tell you it's 15 degrees or 25. They don't normally do it that way. They normally do it like this. The sine of theta is 4/5, and theta is in the second quadrant. Find the sine of 2 theta, right? That's a much more natural kind of type of question. Okay, so jump right in. Let's try one. The sine of theta is 4/5, and theta is in the second quadrant. Right? So that's the information that you're going to work with, right? Some angle theta has the property that its sine is 4/5. That's an exact value. And you're also told that theta is in the second quadrant. And we are going to be asked to find all 3 double angles. So we're going to find the exact value for the sine of 2 theta, the exact value for the cosine of 2 theta, and the exact value for the tan of 2 theta.
I have a question.
Yes.
So is the cosine of 2 theta, is that 1 minus 2 sine squared theta?
Yeah.
So that's the actual formula. It wouldn't be the cosine squared theta minus sine squared theta.
It's that one. It's actually, well, let's tell you. The sine of 2 theta only has one formula. It's 2 sine theta cosine theta. The cosine of 2 theta actually has 3 formulas. Each one gets you the same answer. Right? So it doesn't matter which one of the 3 that you use. Cos squared take away sine squared will get you the right answer. 2 cos squares take away 1 will get you the same right answer. And 1 take away 2 sine squared theta will also get you the same answer. So there are actually 3 versions. So you might say, well, which version should I use? I guess whatever one you like, or whatever one you think's got least amount of work in it would probably be the one I would pick if I had a choice. And the tangent of 2 theta only has one formula. So the odd one out here is that the cosine of 2 theta has 3 equivalent formulas, all work. You can pretty much pick whatever you like. If you get bored, you know, pick the second one, you know, just to be different. Are we good? Right.
Yeah, thank you.
First thing you're going to do, let's break it into my step. Step 1, use the equation or the trig ratio that we've been given to build a triangle. In particular, build a right-angled triangle. So here's my right-angled triangle, and I put theta there. Doesn't this look just like the question I finished a moment ago, right? You name the sides, right? So far, so good. Now, I'm going to write this guy over here again. Okay, what is, according to SOHCAHTOA, what is the sine of theta equal to?
Opposite over adjacent.
You all comfortable with that? Great. Which means that I can now say that the opposite is, did you say opposite over adjacent? You did, didn't you? Or did I write it?
It's
What
opposite over
is,
hypotenuse.
thank you. That's fair. So I thought for a minute it was me that just misheard you. 4 over 5. Now that means that we have one missing side. If you do enough of these, don't you start getting used to certain triangle combinations that happen a lot? Do you recognize this one as the 3, 4, 5 triangle? Right. That's 3, but for completeness sake, let's prove it to you. 5 squared plus the adjacent squared. So I'm saying 5. Try that again. 4 squared plus adjacent squared equals 5 squared. 16 plus the adjacent squared is 25. The adjacent squared, 16 away, gets you 9. And so the adjacent is 3. We'll continue this in a minute. Let me do a little side thing. There are certain right-angled triangles that get used a lot. And if you get used to them, you can actually just find the third missing side by recognizing it. One of them is the 3, 4, 5 triangle. You seen that guy? Actually, that one's very famous. Do you know the Egyptians knew that, and so did the Chinese? They knew that if you, so when they were trying to build things, you know, make corners of buildings, they just had a cord that had 3 knots in it, then 4 knots in it, and 5 knots. And they just stuck pegs in to make the thing taut, right? 3 knots, 4 knots, 5 knots, made it taut. And they knew that they'd built a really good corner. That's how they made corners. Has anybody seen that guy? Because that's also quite common. What's the third missing side when you see that happening? Some of you, it's quite unlucky.
Isn't
It is, it's 13. Yeah. Hopefully that's the unlucky one, right? So that might. You ever seen this one? Right, that's a
Yeah, we
very
just
common
used
one.
that one.
But we just did that one. But if you look back at other questions, I bet you that triangle has happened more than once, you know, in the last 6 weeks. So you agree? In fact, I think all 3 of these triangles, whenever triangles happen. So if you've got a good memory, you can just save yourself a little bit of work, can't you? By saying, oh yeah, I know that one, the 5's missing. Oh, I know that one, the 13's missing, right? Whatever it might be. So back to this question. Step 1, use this guy to build a right angle triangle. Done. So far, so good. Now, to be able to find these guys, where did I put my formula sheet? Here we go. To be able to find these 3 guys, do you notice that the formulas uses sines, cosines, and tangents? Agreed? So once I've built that triangle, I'm going to write down what the sine, the cosine, and the tangent are equal to. Well, I know that that guy's 4/5, but just for completeness sake, I'll put it back down again. Now, according to SOHCAHTOA, isn't the cosine the adjacent over the hypotenuse, which is 3/5, and isn't the tangent opposite over adjacent, which in this case is 4/3? And here is where the mistake happens. This angle is in the second quadrant. Is the cosine positive or negative in the second quadrant? And there's your all sine, tan, cos.
Negative.
Yep. And so that one is negative. What will the tangent be in the second quadrant?
Also negative.
Right. Can you see that if you don't put the right plus or minus on them, isn't your answer going to be wrong just because of that, right? So make sure that when you're building your triangle, you keep everybody positive, right? But once you transfer it over to the 3 trig ratios, which are going to be using all of them, right? Make sure that you take account whether it's a plus or a negative answer, right? That's a big step, but that's a lot. Step 2. Use the formula and simplify. That's it. 2-step process. Now, I got all these guys here, right? And I will bring them back in a minute, but I'm going to do the sine of 2 theta, which is easy because there's only one formula and it's going to be that one. Okay. Now I'm going to do the cosine of 2 theta. Anybody got any preference to which one you want me to do? I don't care. They all work. You like that one? You like the middle one? You like the bottom one? Which one do you like?
Middle one.
Middle one. Okay. So we're going to do 2 cos squared theta, take away 1. And then to finish with, I'm going to do the tan of 2 theta. And that's 2 tan theta over 1 take away tan squared theta, right? Now I've got all the numbers, all the fractions. So this one here is going to be 2 times 4/5 times negative 3/5, and that is negative 24/25. Finished. Now you decided to do this version. So 2 times negative 3/5 squared, take away 1. Well, that's going to be 2 times 9/25 take away 1. So that's 18/25 take away 1. And that guy ends up being negative 7/25. But you can actually do most of this on your calculator. So I'm going to do that and get this answer right off the bat, right? So it's 2 times, put a bracket around it, negative 3/5 squared. subtract 1. Then I'm going to go math, number 1, enter. See, negative 7/25. So last one, 2 times negative 4/3, 1 take away negative 4/3 squared. Would you agree that's a very good candidate for, can we not just let the calculator do it, please? Because there's an awful lot of things going on there and I might hit the wrong button or I might do the wrong calculation. Yes, you can do that. The only warning is you need brackets. So you go a bracket, 2 times another bracket, negative 4/3, close those brackets. Now you might not need all of those brackets, but it's just safety. I figured out I'd rather give an extra bracket that I didn't need than miss one out. Now I'm going to go divide, and I'm going to start with another bracket, 1 take away, put a bracket, negative 4/3, close the bracket, square it, and close the bracket. Boom. There's that part. And then just finish with math choice 1. And the answer is 24/7. Would you agree, isn't that much easier than trying to do it, you know, with a whole load of squaring and adding and multiplying and dividing of fractions, which you certainly could do, but would you agree that's just cleaner? Plus, don't you get the plus minus a little bit safer? How do you feel about that process? Does it feel, you know, are you comfortable with it? Does it feel it's logical? Right. Okay. Let's do another one. I think this time I'll pick as my example one of theirs. Okay. Hold on a second while I find one. Let's do question 2. We're being told that the secant of x is negative 4, and we're told that x is in the second quadrant. Going to change, and we're being asked to find sine, cosine, and tan, right? The double angles. This guy, I don't like. I'm going to turn this guy into a cosine. What will the cosine of x equal if the secant is negative 4?
Negative 1/4.
Right. Now, the reason I want to do that is, don't we have SOHCAHTOA? And doesn't SOHCAHTOA need a sine, a cosine, or a tangent, right? So don't give me the cosecant. Don't tell me the secant, don't even tell me the cotangent, right? I want one of these guys. And that means I can then do adjacent over hypotenuse. So when I'm creating my right angle triangle, and I guess we'll call that X then, I have an opposite here, I have an adjacent here, and I have a hypotenuse here. And the guys we've got are 1 and 4. Right, adjacent over hypotenuse, 1, 4. Going to have to do the opposite, right? Anybody want to try do it in their head? Because if the numbers are reasonably nice, you can do these in your head.
It's the square root of 15.
Does that seem reasonable, guys? 16 take away 1. Right. The more you do, the quicker you get. If you don't feel comfortable with that, can't you do the Pythagoras thing, 3 or 4 lines down here and get the same answer? Now, I'm going to set up the sine of x, cosine of x, and the tan of x, because these are going to be the building blocks for the double angles. And okay, well, the sine is opposite over hypotenuse, and opposite in this case is square root of 15 over 4. Is the sine going to be positive if the angle is in the second quadrant? Is the sine positive in the second quadrant?
Yeah.
Yes.
Okay, so this fella is now the adjacent, right? And the adjacent of the hypotenuse, actually, I already know that answer, so I won't even worry about it. Right, the tangent then is opposite over adjacent, and that's root 15 over 1, which is just root 15. So the same question I asked here and here, I'm now going to ask here. Is the tangent positive or negative in the second quadrant?
Negative.
So do you see we've now got the 3 building block guys? All you need to do now is find sine of 2x, cosine of 2x, and the tangent of 2x. And this fella is going to be 2 sine x cosine x, which is 2 times square root of 15 over 4 times negative a quarter, which I get is negative 2 square root of 15s over 16. Okay. Cosine. I'm going to do the first one. So I'm going to do cos squared x take away sine squared x. So that guy is negative a quarter squared. Take away that guy, which is this guy squared. So that's what, 1/16 take away 15/16 is negative 14/16, which I believe is negative 7/8. Or I could have done it in the calculator, I guess. And the tangent is going to be 2 tangent x's over 1 take away a tangent x squared. So it's going to be that guy. So 2 times the square root of 15, negative the square root of 15. 1 take away the square root of negative 15 squared. Top guy, negative 2 root 15. Square root of 15, positive or negative doesn't matter. When you square it, you get plus 15. 1 take away 15 gets me negative 14. 2 negatives get me a plus, and it simplifies. So the final answer is positive root 15 over 7. You feel good about that one? We good? Right, let's do one for you then, because if you can do this one, then I'm comfortable about moving on to half angle formulas. I'm not sure we've got time to do that, but we'll see.
Can you go over how you got the positive root 15?
Yeah? Is it this one where my finger is pointing?
Correct.
Okay, the top answer is negative 2 root 15. The bottom answer is negative 14. So 2 negatives cancel out. So that's why the answer is positive. And 2 and 14 cancel down to give me 7.
Okay, thank you.
Okay. Let's do mine. I like theta. So the tan of theta is negative 1/3. And I'm going to tell you that theta is in the 3rd quadrant. And your job is to pick any one of the 3 that you like, because you won't have time to do all 3, because I'm not giving you enough time to do that. So find the sine of 2 theta, find the cosine of 2 theta, or find the tan of 2 theta, right? Whichever one you like. And you have got 3 minutes starting from now. For those who need just a little bit of help, there you go. There's a little bit of help, and that's as much as I'll give.
I thought tangent was positive in the third quadrant. Okay.
You're right. Make it fourth. Did you all catch that deliberate mistake there?
I don't know it was deliberate, but it was messing me up. I'm not-
No, it wasn't.
I
deliberate.
gotta
It was,
agree with
it was just a mistake. But I keep saying a deliberate mistake because, you know, some of you are more gullible than others. And I normally tell you I'm going to make a mistake when I do those, don't I? I'll say something like, I'm about to do a mistake. Okay, here goes. We have an opposite, we have an adjacent, and we have a hypotenuse. And the opposite is 1, and the adjacent is 3, and the hypotenuse ends up being the square root of 10. Do you all agree on that? Now sit over here. The values that we're going to use in our double angle formulas. The sine is 1 over root 10, and in the fourth quadrant that's negative. And the cosine is going to be 3 over root 10, and in the fourth quadrant that's positive. And the tangent is going to be negative 1/3 because we already know that. I'll start with the first one. So for those of you who chose to do the sine of 2 theta, which if I was you, I probably would have picked that one because isn't it the easiest to calculate? It's going to be 2 times that guy times that guy, which ends up being negative 6 over 10, which actually ends up being negative 3/5.
Were we
Does
only
that look
supposed to
good?
do one?
Say again?
Were we only supposed to do one of them?
Oh, no, you've done 2, that's great, but I only gave you time to do 1. So if you did more than 1, you're really shifting, right? For the one that I've done, does that look good, guys? Yeah, okay. So I'll now do the cosine. I'll do 1 take away 2 sine squared theta because I haven't done that version yet. So that's going to be 1 take away 2 times that guy squared. That guy is basically 1/10. 2 times 1/10 is a fifth. So I get the answer 4/5. That look good? For those who did the cosine. For those of you who were adventurous and tried to do the tangent, which I would say is the hardest of the 3, you're going to use that formula. And it's going to be 2 times negative a third, 1 take away negative a third squared, which is what? It's going to be negative.
Negative 3/4.
Thank you. Negative 3/4. But I'd probably have done that in a calculator if I had time. So if I give you any one of the 6 trig ratios, right, tangent, secant, sine, and I also tell you correctly which quadrant it's in, do you feel happy you could find all 3 double angles? You comfortable with that process? So rather than talk about the half angles, let's start that tomorrow. Instead, let me show you a different puzzle. Simplify that expression. This is essentially question 3. Right, so rewrite that in a simpler form. That's essentially what they want. Do you recognize anybody here that looks like that guy? I can. Can you see it? This one. Isn't that the formula that's here? So isn't that the tangent of 12 degrees? That's what they wanted there. That although I don't know what this is equal to, I do know that it's going to be the same thing as whatever the tan of 12 degrees equals to. How about this one? Two times the sine of 5 degrees times the cosine of 5 degrees. Who would
We
he
sine
be?
of 10.
You know, sine of 10. I guess for completeness sake, what would that be the same as?
25. What, cosine of 25?
Agreed. Isn't it just a matter of looking and seeing who he is, and then realizing it's the double of 5, the double of 12 and a half, or in this case, the double of 6, and recognizing tan, sine, or cosine as well. And this is a very nice place to finish. So last name, and bye-bye for now. And I'll hang about for any questions. And tomorrow, half angles is going to be our thing. Any questions, Josiah? Ben? Are we good? Okay, bye-bye, guys.
I had one question.
Sure.
So I missed the first meeting this week,
Okay.
and because of
Hey.
that, I was, I guess, a little late, and I'm still. So I've worked through almost all of the second section, but I still haven't figured out problem 9 for the first section, which
Okay.
is
Let me have a look at it. Number 9, trig identities. I just want to get yours. That way I can.
yeah,
Come
it's
across
6 over 1 minus sine A plus
Okay.
6 plus 6 over 1 plus sine A.
Okay. So 6 over sine A plus
That's 1 minus sine A.
1 minus sine A. And the other number,
Yes.
what's this guy?
6 over 1 plus sine A.
And is it equal to something? Because typically it would be. Or does
No.
it just simplify it?
Simplifies.
Simplify it, okay. So what I'm going to do to this mess here is I'll write it again now a little bit near. Is I'm going to take this fraction and multiply it a special version of 1. And then I'm going to take this fraction and I'm also going to multiply it by a different version of 1. And the reason I'm doing that is I want to add these fractions together. So the only way you can add fractions is if they share a common denominator, and right now they don't. So the special version of 1 I'm going to do to this guy is I'm going to multiply it by 1 plus sine A. And for this one, I'm going to do 1 minus sine A. Now the net effect of that is that these two fractions will now share a common denominator. And that common denominator is a 1 minus sine A followed by a 1 plus sine A. Right? Now if you take these two and multiply them, you'll get 6 plus 6 sine A. And if you multiply these two out, you get 6, take away 6 sine A. And these cancel out, and these become 12. So far, so good. Now, I'm going to FOIL this out, and to save some time, can you trust me that that's what you eventually get? Because the plus sine A and the minus sine A cancel out, so you're only left with 2 terms, right?
Okay,
Now,
yeah,
what
yeah,
you-
that helps a lot.
So what you now do is recognize that 1 minus sine squared can also be written as a cos squared. Right? One of our list of things that we know, one of them at least, is that 1 minus sine squared is cos squared. And then we don't like fractions, so I'll just convert it to a secant. So 12 over cos squared becomes 12 secant squared A.
Repeat that last